Hello, welcome to another Unity game developer video. Back working on the snake game again. I've been calling it a snake game up until this point because that's what the project most resembles so far, with the kind of windy character like that, but that's not what I was planning on doing. I guess I'll do a description of what the game is going to look like from what I've been planning. More of kind of similar to a Pikmin type setup. Not in the way where you would have many characters like following as a group and you would kind of utilize them as individuals with their particular skills or abilities, but more of a saving individual characters and then they become part of this longer string, and then that just adds to this one ability so far. And so far that ability is what I'm going to show off right now, and it's kind of like a climbing system. But as you can see down in the player view right down there in the game view, I have it set up so that when I press space, the character goes straight up, and it looks almost like whatever the main character would be is standing on the shoulders of the characters that are rescued. So the parts that are added to the array as you rescue characters are the blue sections, and the main character is the red section. So if I were to just add some more to the array, I can climb even higher. I have it set so it does it roughly about the height of the stack, and that's about as high as you climb, depending on how many people are in the array. So I think that is an interesting system. Right here, it's not fully stacking because you can see that there are some parts of the array that aren't being utilized for the climbing, and I'm not quite sure why that's happening yet, but I'll look into it. But imagine for right now that there was only these 4 that are actually stacking. They are not stacking, and imagine that ramp isn't there. They are not stacking enough to reach this next section, so you would have to rescue more characters to progress. So down in the game view, I'm going to pick up these little nodes here that are just the stand-in for rescuable characters. I'm going to go back over here where you can see it, and now I have a lot more in the array, a lot more that have been rescued, and I can go higher. So now I can make it all the way up here. And I think that's kind of an interesting way to limit progression with a finite requirement. So the way this is working, and I'll show in just a second, the way I have this set up is these objects that are in the array, I am taking this target object, and that target object is lerping to a object that is set above it, and I will show you right here on the side. It is called the climb top target and climb bottom. So let me explain what's going on here. I will select the climb bottom, and right now it's just an empty object in the scene, but when I go into the game view, you'll see exactly what it is. So it is directly below. Oh, well, that explains it. That's why it is not letting me go very high when I'm on this second plane, because for some reason it is not placing the ray point on top of this object. But what's happening is that the target object is shooting a ray cast directly down, and when it finds the ground, it is finding the distance between the target and the ground, and it is placing the climb bottom object at the very bottom. And then this climb top target is exactly a particular distance based off of the amount of objects in the array above the target. So as you can see, there's 3 objects in the array. It's roughly 3 above the target. If I add more to it, it moves up, and that's where this object is lerping to, and then it goes back down to its original state because it is a physics object. But that is directly above that climb bottom object. So let's jump into the script and I'll show you exactly how I'm doing that. And I believe that script is on the target object in a script called climb. It's right here. So I have the camera. That is just, I have the camera in the script because it is grabbing the perspective of the camera, not used for any part of the climb, but more for a limited access to the climb. I wouldn't want it to climb, you to be able to climb like that in first person because it would be kind of disorienting, so I have it only set when it's in the overhead camera position, which is how the cameras work and how I explained in the last video. So it is grabbing this snake object, but that snake is just a title for an access to the level script, which is what is grabbing and making the arrays for the snake object. So, and the reason I have that is I have a variable within the snake object called v, and that is that is accessing the length of the array for the snake object, so I know exactly how many characters have been saved or rescued or whatever in the array, so I know exactly how high the character can climb at that point. So if I go into the script and we look at it, let's see. Okay, so what's happening is that climb bottom object, it is taking is placing it at a new vector 3, which is at the transform position of the target dot x, transform position of the target dot z, and it is placing at the transform dot position y of the target minus that distance that I was telling you about with the raycast. So it is always going to be at the ground where the raycast is hitting. Right now the raycast is not hitting those block objects in the scene. I'll have to look into that, probably some exceptions based on like the layers that I've set up so that it doesn't hit the body segments and such. Because if I didn't add those exceptions with the layers, it would just keep hitting the bottom segment when it's climbing, and it would keep placing the top section above it. So it would go here, it would place it here, like that, and it would just keep going forever, and it would just fly up, which is obviously not what we want to happen. And this climb top target dot transform position, I will explain this in a second, but that is still up to change. That might end up different, but right now it's kind of good. I like how it works. So we have the transform.x. This target is being climb top target is being placed at transform.x, transform.z, but it's also being placed at the transform position of the climb bottom object that's always at the ground dot y plus the scale reference of the body segments. So generally the diameter of the body segment. So that diameter of the body segment, the distance between the body segments, times the amount of objects in the array minus 1. So it is finding the amount of objects in the array, and it is placing at that exact distance. So if it was moving horizontally, it's generally the same distance that it would have horizontally placed vertically. So I think it's a good result from that. I might decrease the distance to spawn for the waypoints for the follow object script. I might decrease the distance to spawn while an object is climbing, so I get more of that standing on each other effect, so they're not spaced out at all when it's climbing. I might not do that. Either way, I'm planning on making these characters probably like bugs, not like maybe like ladybugs and like other small bugs that have wings, so they won't really have to stand on each other, and it'll just be aesthetically pleasing. Nobody's going to question why the bugs don't just fly, but they'll just be spaced and they'll be fluttering the whole time. But I think that would be good. And also, if I give the bugs wings, that'll put them in interesting places to be rescued. so I could have them up a ramp or in a particular spot where you have to climb to get them. Um, so when I am pressing space, if the space key is held and the camera is in that overhead position, the transform of the target object, well, it stopped using gravity because when it's lerping to that upper target position, if it is using gravity, it'll kind of fight it a little bit, so I just turned it off for that instance. And I disable the controls for when it's climbing because there's no reason to move around while it's climbing. I mean, that could be an interesting mechanic, but I'll just look into it later. It doesn't sound like it will be very useful. And I zero out the velocity of the object because otherwise it'll just like fly into the wall when it tries to stop and then climb. That might be it's interesting because that might be a slight abuse for stopping so quickly. I might have it enact a counter force to how quickly the object is moving until it zeroes out the velocity, and then add the make it lerp to that top position, because if they're moving 1,000,000 miles per hour, it would be pretty unrealistic and probably game breaking if they just instantly zero the velocity and climb. So then they climb up to that object, and here I have it climbing at the speed. I have a rise speed that's just obviously how fast it moves to that target position, but I have it divided by the length of the array for body segments, so it is normalizing the speed. So no matter how many objects are in that array and how far that target is up, it is going to take the same amount to get there every time, the same amount of time. Because when you are creating that value in the vector3.lerp, that final value for the third section here, that overload, it's determining how long it should take for it to get there. And if you have 0.5 in there, it's going to get up there pretty quickly. But it's going to take the same amount of time. Let me reiterate what I was saying earlier, just change it up a bit, because I was saying that I normalize it so it would take the same amount of time to get up there every time, but that's actually the opposite of what I'm doing. I misspoke. I didn't normalize it so it would get there at the same time. I normalized it so it would climb at the same rate, despite how the distance between the two target objects. So if it was trying to lerp there at 0.5 on the rate right there, it would be just going there as fast as it could, based on that time that you put on there. But if I am dividing it by the amount of objects in the array, it'll normalize that distance, and it'll just go there at the same rate. So that's a little nifty way to normalize that. And then as soon as you let go of the space key, gravity is restored to the physics object and the controls are restored. This input.getKeyUp section is I was going to enact the slight jumping force at the end, so you would climb, and then once you got to the point and you let go, it would do a little hop. So I think that would be nice. So that's how I implemented that, and I think it's pretty cool. So I'm just going to go back and look at it one more time, show you guys. Going up to the wall, and climb, not tall enough, rescue a few guys, go up to the wall, climb, and I can reach it. Go to the wall, climb, not tall enough. In this instance, it is catching the ground here as the distance to the ground, not to this block, so bear with me and imagine that it is working properly. So you have to rescue some more, and then climb again. And then theoretically, you rescue plenty, you would be able to reach any height. Any height in proportion to the amount of objects in the array. So I just rescue a bunch. Let's hold shift in one, and then I just hold space. And even though it has a ridiculously high target position, as you can see down here, it is still moving at the same rate that it would if it was a lower target position. climbing, and they're all going underneath and picking it up, almost like it's standing on their shoulders. Let go. And the hop will also make that a lot less jarring at the top where it falls off like that. Obviously, it would be more aesthetically pleasing if it was kind of a loop or a little arc at the top instead of just a straight down line like that. So that's all I wanted to show you guys, and thanks for watching. If you haven't checked me out on Twitter, my Twitter is at cyberbully20xxd. Check me out on there. I'll post more game developer stuff, and I have some 3D modeling that I do on there, which is different than this. So thanks for watching.